Hi. This is my roommate.
Hi.
Would you like to introduce yourself?
Hi, my name is Guadalupe.
Okay. We're gonna be learning about binary numbers. So, here's this. What do you notice about these cards?
Each card has twice as many dots as the one on the right.
Yeah. So like 1, 2, 4, 8, and 16. So then, moving on. So the binary system uses zeros and ones to represent like the entire system. So for this activity, zeros and ones will represent whether a card is face up or whether it's not. And for this activity, 0 would show that a card is hidden, while 1 means that you can see this dot. So for example, right here, you would see 1, 0 because it's hidden, 0 because it's hidden, 1 because you can see it, and 0. So the way that the binary code works are we're going to be counting the ones all together. So right here, there's 1, and then there's no more, so we don't add to that. Don't add to that. And there's another 8 right here. So you would add the 1 and the 8 since we want to add up the ones, which will give you
9.
Yes. Okay. So this is going a lot faster than I thought. Okay. So based off of that introduction, I have this little worksheet prepared for you in which we're gonna guess. So I want you to write out zeros and ones for the first set of cards and how much it totals up to be. So for example, the first one looks like that. If you need more of an explanation, I can give you another explanation for it.
So like right down here.
Yeah, for like the first set of cards. Mm-hmm. Mm-hmm. Okay, now what does it total up to be?
5.
Yeah. Okay. So my roommate, I don't know if you can see that. 1 0 1 0 0. Pretty proud. Added it up to 5. Wow. Wow. Okay, now do the next set of cards. You're doing so good. Okay. How much is the total? For reference, she did 1 0 1 0 1. So what numbers do we add up?
This one. 60. 4
Okay.
and 1.
Yeah. Just for reference, a binary code, we always start off from the right to left. So like opposite of how we would regularly read. So we'd start off over here to add up. So 1, then 4, then 16, which would equal
21.
Okay. Wow, you're doing so good. Okay. So then for the next thing I'm going to do, I have blank cards, 2 blank cards right here. And I'm going to just give her numbers so that she can try to figure it out. Okay. So we'll do 19 for the first one. Actually, no. Let me do 12 so that it's semi-easier for her. So remember, we always start off, well, when we're adding up, like figuring it out, the binary code, we'll always want to start off with the bigger numbers. When we know them, we read it right to left. When we only know the number and not the actual binary code, we'll read it left to right. So you're going to want to get rid of the bigger numbers. So 12, will there be 16 dots in that one?
No.
Okay, so that's going to be 0. Then this is 8. Will there be 8 dots in the 12?
Yeah.
Okay, so draw 8 dots. And then mark it as a 1.
I'm sorry.
I was supposed to print this out. Keep working. I was supposed to print this out, but the printer would not work at the Ed building, so I am forced to work on this on my iPad, just for reference. Okay, yes. So now that we have 8 down, we're gonna subtract 8 from that, and we have 4 left. And then the next card has 4 dots. So we're gonna add that in. So I'll draw the dots for you to make it faster, since you like making them perfect. So then that would be a 1. And since we have no more left over, these are gonna be 0. So what's the code?
00110.
Yeah. 00110. Okay. Well, you did so good. Okay. Now, let's see. I want you to make 35. It's okay. So, once again, left to right when we don't. This number is called the decimal number, by the way, which is like the amount of dots that will be totaled up. So, right here, in the very last one that we have over here, there's 32 dots.
Okay.
So, would we add that?
Yes.
Oh, yeah. Minus 32. So then I'm just going to draw scribbles to represent, and then that would be a 1. Okay, so then we have 3 left. The next number over here, the next card over, is 8 dots. Would we include that?
No.
Okay, so that's a 0. Next one has 4.
No.
Okay, 0. And then this one has 2.
We would include that one.
Yeah, so 1, 2. So that's a 1. And then this one has 1.
We would also include that.
Yes. So then we got to 32. And can you read the binary code for me?
11001.
Yes. 11001. Okay, she's doing so good. So good. Okay.
Yeah, you know.
Don't hype yourself up too much. Okay. I have some more cards over here. This is what that one looks like. I want you to add it up and then tell me the code for it.
I have to record again.
Sorry.
Okay. Do I tell you?
Mm-hmm.
Okay, I got 29 for the first one. Is that wrong?
Hold up. Oh no, you're right.
Okay.
Okay, and then the binary code.
10111.
Excellent. Scholar. Okay. So if we had a binary code that's 1111, like all of them are 1, what would the total be?
5.
The decimal number. How many dots would there be?
Oh, 1. No.
If the binary code is 1, 1, 1, 1, 1,
Mm-hmm.
how many dots would there be? We add up all the ones.
5.
So 1 plus 2 plus 4 plus 8 plus 16.
Oh. 31.
Okay. So that's all I have for right now. Did fantastic. As for assessment and how I'll show my students have learned it, I'll create like a more lengthy worksheet. So probably like about 2 of those pages. And then I would have the students figure it out based off of like the decimal number that I give or based off of the dots that I give, and have them write out the binary code for each. But that's all. Logging out.